Student A tries to define a function g from q to z by the rule g of m over n equals m minus n for all integers m and n with n not equal to 0. Student B claims that g is not well defined. Justify student B's claim. This video is going to talk about what it means to be well defined. To be well defined simply means that this function definition makes sense with this domain and codomain. Now, a function has to have the property that for every input in the domain, there is an output that's in the codomain. Now, to say that a function is not well defined means that there is a severe problem with this function definition. Now, in order for this function to be well defined, it must be the case that for every input in the domain, there must be one output from the codomain. For example, g of 1/2 would be 1 minus 2, which is -1. Now, there's no problem here. This is perfectly fine as it's written. The input is an element from q, and the output is an element from z. So there's nothing wrong with what is presented so far. But there is a deep problem with this function. Namely, the fact that fractions can be represented in multiple different ways. For example, the fraction 1/2 is the same fraction as 2 over 4. Now, this is an unsimplified version of the fraction 1/2, but these are different representations of the same number. And so if I'm plugging in the same input, I should get the same output, -1. But let's take a look at what happens here. This is 2 minus 4 according to the rule of the function, and 2 minus 4 is -2. And so when plugging in the same input, we get two different outputs, which violates the definition of a function. A function must satisfy the property that for every input in the domain, there must be one output. But here we have one input in our domain. Even though it's represented in two different ways, it's the same input corresponding to two different outputs. These two outputs are not different representations of the same thing. These two outputs are genuinely two different outputs. -1 and -2 are not the same numbers. And so this function is not well defined, and so student B is correct. And we can really do this with any fraction. You can take any fraction and write it in many different ways. And in order for this function to be well defined, the output has to be the same regardless of the representation of our input. There are some functions that have function definitions with this sort of representation of a fraction as the input that are well defined, but not this one. Thanks everyone, and I'll see you in the next video.